Bismillahirrahmanirrahim. Assalamu alaikum students. This is Hamza Noor, and here we have a question. October November 2019, paper 43, question number 5, Mechanics 9709, A level maths. So the question says that a cyclist is traveling along a straight horizontal road. The total mass of the cyclist and his bicycle is 80 kg. His power output is a constant 240 watt. His acceleration when he is traveling at 6 meter per second is 0.3 meter per second square. Show that the resistance to the cyclist motion is 16 Newton. All right. So the first thing first, what we know is that the power is equals to force multiplied by that speed. Force multiplied by speed. This force is the driving force. This force is not a net force. So never make a mistake of considering this force as a net force. This is not the net force. This is the driving force. So I can say that power is equals to driving force multiplied by speed. Since I know the value of power, which is 240 watt, and the driving force is unknown right now, and the speed is 6 meter per second. So we can say that driving force is equals to 240 divided by 6. The driving force is equals to 40 Newton. As simple as that. So the cyclist is traveling along a straight horizontal road. So let's consider that cyclist and the bicycle as one complete particle, one single particle C. Okay, and the total mass of the cyclist and his bicycle is 80 kg. So weight is acting vertically downwards 80 g, and this is a normal reaction force Rn. All right, and this is the driving force which we have found, which is 40 Newton. We need to show that the resistance, which I'm saying Rs, we need to show that the resistance is 16 Newton. Okay, so now you need to use the Newton's second law of motion. Net force is equals to mass times acceleration. So driving force minus the resistance is equals to mass times acceleration. The driving force is 40. The resistance force is unknown. This is equals to mass times acceleration. Mass is 80 kg and acceleration is 0.3 meter per second square. So 40 minus the resistance force is equals to 80 multiplied by 0.3, which is 24. Therefore, the resistance force is equals to 40 minus 24, which is supposed to be 16 Newton. Here you go. You have your 3 marks. Let's move on to the next part. The next part says that find the steady speed that this cyclist can maintain if his power output and the resistance force are both unchanged. The power is 240 watt and the resistance is also unchanged. The resistance is 16 Newton. So we need to find the steady speed. So obviously this steady speed means that the acceleration is equal to 0. Steady speed means acceleration is equal to 0. Steady speed means constant speed. All right. So driving force minus the resistance is equals to mass times acceleration. So since we know the fact that power is equals to F multiplied by V, where F is the driving force. So power is equals to driving force multiplied by the speed. So if I want to make, I want to use the driving force over here, right? So if I make a driving force a subject of the equation, so this is equals to P divided by V. So the power is unchanged, it is 240 watt. So I can say that the driving force is equals to 240 divided by V. So in place of driving force, I can write 240 divided by V minus the resistance. It is the same 16 Newton. This is equals to mass times acceleration. And since we are talking about the steady speed, which means constant speed, acceleration is supposed to be equal to 0. Here you go, just solve this equation, find the value of V. So 240 over V is equals to 16. Therefore, V is equals to 240 divided by 16. That is that steady speed is 240 divided by 16, which is 15 meter per second. Here you go, you have 2 marks for the next part. Part 3 says that the cyclist later ascends a straight hill inclined at 3 degrees to the horizontal. His power output and the resistance force are still both unchanged. Find his acceleration when he is traveling at 4 meter per second. Okay, so we need to find the acceleration when he is traveling at a speed of 4 meter per second. So now the cyclist is traveling on a hill which is inclined at 3 degrees to the horizontal. here we have the here we had the journey in part 1 and part 2. Now he is on the inclined hill which is at an angle of 3 degrees to the horizontal. Now the cyclist, that particle C is over here. Okay, the cyclist and his bicycle. So since the mass of the cyclist was 80 kg, right? So weight is acting vertically downwards, 80 g. Since this angle is 3, so this angle is also 3. So this component is 80 g cos 3, and this component along the plane, along the hill, is 80 g sine 3, and this is the normal contact force acting perpendicular to the hill. Okay, so his power output and the resistance force are still both unchanged. So the power is 240 watt. Okay, so since we know that power is equals to driving force multiplied by speed, so power is 240. The driving force is unknown right now, and the speed, we are talking about the speed of 4 meters per second. So in this case, the driving force would be 240 divided by 4, which is supposed to be 60 Newton. So the driving force in this case is 60 Newton. And the resistance is unchanged. The resistance is the same, 16 Newton. We need to find the acceleration. Now you know what you need to do. Use the Newton's second law of motion. Net force is equals to mass times acceleration. So 60 minus 16 is equals to mass times acceleration. Oh, sorry. And one more component, 80 g sine 3 as well, which is along the plane, which is acting downwards. So 60 minus 16 minus 80 g sine 3 is equals to 80 times A. So 60 minus 16 minus 80 times 10 times sine 3 is equals to 80A. Therefore, 60 minus 16 minus 80 times 10 times sine 3. This gives you 2.1312. 2.1312 is equals to 80A. Therefore, acceleration is equals to 2.1312 divided by 80. Acceleration is 0.0266 meter per second square. Correct to 3 significant figures. Here you go. You have 3 marks of the last part.